Good morning and welcome back to the enclosure. As you can see, we've made some progress on the HVAC room. I have been waiting a long time for various fittings. For instance, this brass cross took me about a month and a half to get. And the flush fittings here, this is going to be for a sensor. That took about 3 weeks to get. The Webstone purge valves, that was about a month and a half to get. So it's been a little bit challenging waiting for parts, and I've been basically doing some unpacking and cleaning at the times where I wasn't able to do anything. But we're just about finished. I've got one flush fitting adapter there to a 1/4 inch thread that I need to put the sensor in, and then the piping is basically done. I need a pressure and temperature relief valve for the tank, which I'm waiting for the manufacturer to tell me which one to use. And in the meantime, I have started the work on the electrical. There's 226 individual terminals that I have to at least plan. Not all of the terminals are used. There's some, for instance, terminals on the DX2W that will be not used. And there's some terminals on the iStat6 devices that won't be used on the ones that are upstairs. Down here, we're using the majority of them except for the analog outputs. But basically, I've got power coming in, and it's a little bit dark here. Let's see if I can give you some more light. I've got power coming into a 30 amp circuit, which was going out to the back shed, but I've run out of circuit breaker spots in my panel, so I have put in this sub panel to split off a 15 amp, and that really is just for this circulator here, which only draws roughly about an amp, and then the various power pucks and transformers that I have here, which draw about another amp. So I'm not drawing too much from the shed circuit. But then we come over to our control cabinet, and I've got a DIN rail with connector strip there for the field connections coming in. I've got various power buses. I'm going to be taking off one of those power buses because we don't need it anymore. Change in plans. And then I've got the actual controls on this hinged cover. And then there'll be a door over top of this as well. So I've got 3 iStats. 2 of them are going to be used for BTU monitoring. So that's going to be determining the efficiency of the system, the science part of what I'm doing. And for that, we've got flow sensors. Above those flow sensors, I'll have some temperature gauges, or just temperature, they're little sensors. We've got the Balon BTU meter. And then we're going to have some various field temperature sensors as well. So we've got 2 BTUs, BTU iStats, and then this one will be for the mechanical, so any of the mechanical controls that are needed. And the iStats allow for a Modbus programming language, which is going to be something I have to come up to speed on. The TD1204 is basically a combiner. It's a hub, and it's combining 4 COM ports into one. That then goes into the iNet, which is sort of like a master controller. And then that goes out to the internet, to the cloud. And we have the ability to program via the cloud. So in other words, any connected PC. I've got some power packs. 2 of these are going to go bye-bye. We don't need any more. We've done a little bit of a change. And then I still have to mount a 24 volt AC transformer here, which is going to power the bus A. We've got our panel circulator. So that's a Willow Maxo. and it is what is going to circulate the water through all of the ceiling panels, and it's on basically a separate loop. It comes over, goes the purge. This is obviously the feed out purging valve, a magnetic and dirt filter, and spiral debubbler, so it takes out all the micro bubbles as well. And we come up to our mixing valve. So the master brains are going to use the outdoor temperatures and figure out the optimal temperature to store the water in the buffer tank. This is in the heating system. And then we're going to be storing the water in the buffer tank higher than what's needed in the panels, just so that the heat pump doesn't have to cycle as often. And then the mixing valve is what takes it down to the temperature needed by the panels themselves. The mixing valve takes in a segment of the water returning from the panels, which is obviously quite a bit cooler, to mix in with the boiler, the holding tank water, to mix it down to appropriate temperature. I've got unions on every place that I need it, so that I can take this assembly out and maintain it later on. I won't have to cut and resolder any of the copper. Most of this copper will be left exposed because it will be at the panel required temperatures. During the summertime, when we're cooling, again, the water coming back now is warmer than the water going out, where this will become a chilled water tank. And so the warmer water will warm up the cold water, so that using the indoor RH sensors, we will be able to determine the dew point of the interior air and make sure that the water going out to the panels is at least a couple of degrees warmer than the dew point, so we don't have condensation on any surfaces. As a result, I don't have to worry about any of the feed piping to the panels, because it's always going to be above the dew point, so I don't have to worry about condensation. I will have to worry about insulating the holding tank lines, as well as the lines going up to the HRV coil, and there's the circulator, because they will be, especially during the summertime, they will be at tank temperature, which is, I think, going to be roughly 45 degrees Fahrenheit. So we will have to insulate these before next summer. So we've got our mixing valve, we've got our ability with various valves to shut everything off so that we can take out it and maintain. We've got our backflow or check valves, so that because this is above, we want to make sure that when the system's off, that we don't get cycling just because of thermal movement of the water. So it prevents water going this way and it prevents water coming this way, depending on whether we're on the supply or the return. We've got the DX2W. I'm just in the process of hooking up the line sets from the heat pump. And I did a little bit of a screw up, so I'm going to have to probably buy another 3/4. I made it too short, and I'll show you that in a sec. And then we've got on the heat pump line, which comes from the DX2W, we've got the bleeders, the scuppers with the auto bleeders on the top. And that comes down to the heat pump circulator. So this is what takes the water being conditioned by the DX2W and puts it into the storage tank. And this is the return to the storage tank. And the valves on each side will help us determine the pressure drop, and that, I believe, helps us to determine the flow. But basically this will be a fixed speed circulator. The HRV coil will be a fixed speed circulator, and then the Willow Maxo will be a variable speed. It will ramp up and down as required to main pressure and flow. The HRV is a Willow Stratus Eco, and the heat pump tank is a Willow Star. Okay, I will now just give you a quick look outside, and then we are done. Just forgot to talk a little bit about the feed station. So this PEX line is the feed to the system. I'm going to convert it over there to copper and bring it down so I can bend the copper around here and then over to the feed. And we've got a backflow preventer, we've got a pressure reducer, and then a shutoff gauge so we can tell what the pressure is in the system. And then this will be where the expansion tank goes, which is right over there. And I just have it out of the way. I don't want to have it installed while I purge the system. I don't want to get any gunk in there. I'll be able to use this to dump the air and the debris out of the system, as well as these purge valves. But that's where it'll end up eventually. Okay, let's head outside. So outside we've got the Generac 22 kilowatt generator, genset, mounted on its poured pad. I'm still doing the final connections, and then I'll have absolute power out to commission the unit, turn it on for the first time and go through all the checks. And then we've got the GREE inverter heat pump, which is just about ready to go. I just have to do some the line set work. So what I screwed up is I wasn't thinking this will actually be below the concrete level of the poured pad, and what I need to do is loop it up and over so that it has an anti-drain loop in it, and that's something to do with a refrigerant. So I'm still in the process of working that out, and I'll probably have to replace the 3/4 line because I had already cut it. Okay, I want to wish everybody a happy holiday, and hopefully in the new year I'll get started on the upstairs, finishing the master bedroom suite and the media room. But for now, happy holidays and happy new year, and we will talk to you soon.